Alright guys, let's continue on the multiple linear regression. So in this video, I'm going to show you how to generate Excel outputs from the Excel and also analyze each one of the elements in our Excel outputs. So let's get started. So first of all, I'll post this Excel file so you can play around with this. So we have four data set here. First one is called distribution cost. Underneath you can run an analysis in your own and then see what you can get out of it. And also we get target rating surveys, and also advertising, also the house. So there are four different data sets here. So we're gonna first of all we're gonna look at the advertising data set here. So now in this data set, there are three different tasks. Right, first one, predict sales using the advertising channel, meaning advertising spending using the radio, and then advertising spending using the newspaper. Okay. All right, so that's one of the main tasks here. Secondly, we're going to predict sales using the advertising channels with the radio, advertising channels using the newspaper, and whether or not there's a recession. Okay. And then later on, we're going to compare models from first model and then from second model, see which one is a better model. Okay. So first of all, let's get to the model number one, right? Okay, so let me just highlight this, and then later we're going to compare these two models. So it's useful to label this. Okay, so for the model number one, first of all, we're going to predict sales using the radio advertising and the newspaper advertising. So first of all, we go to data, and then you're going to see data analysis on the side. Okay. Now you're going to go to regression. Okay, scroll down and see regression here. All the tests we're going to do here is under the analysis tools. Okay. Click on OK. So now from here, first of all, we will look at input Y range, right? So the Y values is sales. We predict sales. Okay. And the input X range, couple ones, radio advertising, newspaper advertising. Okay, both of them. Okay. So we are including the title labels, which is title, and the confidence level is 95%. Right? That's what we have here. And also, we're going to put a result in this sheet. So click on output range here, and click on the arrows here, and I'm going to put it right here underneath it. Okay. No, actually, yeah, let's do that. Let's put right underneath that. Okay, scroll back, and then we can also look at, if you want, you can get a residual plot, but that's not needed. So I guess I will omit that. Okay, so click on OK. We're going to see all the Excel outputs. Okay, so first of all, we're going to see the summary outputs. So let me just quickly format this. Okay. All right, all borders, center, and border. All right, so let's start with the multiple R. Right? R values, meaning this is a strong direct correlation here, and then the R squared tells us 80.87% of the variation in sales is explained or interpreted by the variation in the independent variable, which is radio advertising, newspaper advertising. Radio advertising, and then newspaper advertising. Spending. Okay, So that's basically how we interpret the R square. Okay. Also, we're gonna learn how to interpret adjusted R square. So here the adjusted R square is slightly smaller than the R square, so it will be at 78. So if you want to run this to 4 decimal place, that's okay, right? So it'll be 78.86% of the variation. I will post this solution in our Blackboard course under the corresponding folders. So you can just pay attention to this Excel demonstration here. Operation, sales, it is explained by the variations in the radio, advertising, and newspaper advertising spending. And also, we're going to add another sentence taking into consideration of the sample size and then number of independent variables. This is a very important sentence. And then okay, so meaning adjusted R square penalize any additional independent variable use, right? And also give us a better feedback, better measurements in terms of overall model. Now standard deviation between the dependent variable y and then both independent variable x, it's going to be 158.99041. And the sample size here is 22. 22 sales numbers here. And then in our ANOVA outputs, let's quickly analyze the ANOVA outputs. Okay. Into this. So ANOVA output gives us overall model. So if you look at the p-value here, so this significance F meaning p-value. So the p-value, this is basically 1.50126 multiplied by 10 raised to 97 power. So this is a very, very small number, which is going to be, if you want to turn into a decimal numbers, you can do that. So you just got to format this number right here, go to format sales, numbers. Okay, so just keep increasing the decimal until you see all the numbers. Okay. So I guess it's such a small number, right? So this is definitely smaller than alpha. Alpha is always going to be 0.05. So this tells us we're going to reject HO. HO is beta 1. Let me just quickly remind you. HO is beta 1. Beta 1 equal to beta 2 equal to 0. Okay. So since we reject that, that means at least one of the beta is not 0, meaning that there's a linear relationship between the sales and also those two independent variables. Okay. So this tells us that's with 95% confidence. That's a linear relationship between sales and radio advertising spending. And also newspaper advertising spending. So this is effectiveness of overall model. So we measure that. Okay, now let's take a look at the last outputs here underneath it. I'm going to write a regression model in a second. Okay. Center everything for 12. I'm going to put in all borders. Okay. Okay, so I'm going to adjust a little bit. So let me just quickly write a regression model and then we'll analyze the remaining stuff. Although we know that overall model is effective or it's useful, meaning both, but we're still going to look into each individual independent variables. So right here, the regression model, multiple regression model. So it's going to be predicted sales. It's going to be equal to intercept. That's going to be 156 point. I guess I'll run all of this to 3 decimal place for the simplification reason. Okay. Yes. 156.430. I'm adding, yes, so it's going to be 13.081 multiplied by radio. First one is radio advertising. And adding 16.795 multiplied by newspaper advertising spending. Okay, so that's our overall model. Yes, and also we're going to look into each individual independent variable in a second. Okay, so we get that one done. So you look at so testing the beta 1, right? Beta 1. So if you look at radio advertising, which is a radio advertising, if you look at the t-score, this is so both of these are very, very small. I'm just gonna format sales numbers, as you can see. So this is very, very significant, meaning because the p-value it's so small, right? It's much smaller than alpha. That means we're gonna reject HO. So HO is beta 1 equals 0. 1 equals 0. That means radio advertising is a significant independent variable that we utilize to predict the sales. So radio advertising is a significant indicator of the sales. Another way of saying this is that there's a linear relationship. There is a linear relationship between radio advertising and the sales. So whichever you prefer to express your conclusion about this, right, it's equally good. And we're going to take a look at for beta 2, right? Same thing for beta 2, for B2. For the slope, for the newspaper advertising, beta 2 is a newspaper advertising. So again, p-value, it's much smaller than alpha. The p-value is this. The news highlight those two p-values. It's very, very small. Highlight those we interpret. Okay, and also this value and p-value. Okay, so p-values again is much smaller than alpha, so reject HO, meaning HO is B2 equal to 0, so B2 is not 0, so that newspaper advertising is a useful or effective indicator or predictor of the sales. Whichever you want to say that. Right? You can also say there's a linear relationship between the newspaper advertising and the sales. So this is the second. So we complete the analysis. So both variables are quite significant or useful. So you should keep both variables. So now let's look at the model number 2, which is, so model number 1, we get a 80.87% of effectiveness, right? And just the R squared is 78.86%, which is pretty good. But let's see if the model 2 is going to be better than the model 1. But for model 2, we are including this dummy variable, right? So so right here, I'm gonna show you how to code it. So first of all, right next to resection, you're gonna do an insert. Right click on this insert. Now you're gonna insert, and you're gonna do resection dummy, right? Because resection is a dummy variable. So label that dummy variable. Okay. Now, if there's a resection, you put 0, right? So you do equal to if. Using if, so logical test is if this E2 is equal to recession, yes. If that, meaning if there's a recession, meaning the sales will go down, so we call it 0. Otherwise, it will be 1. Recession will have impact on the sales, right? So that means recession compared to the no recession, the sales will be worse. So that's why we use 0 for recession. Yes. If no, then it's going to be 1. So now we get this. Then you just drag it to get out of the rest of the codings here. Now, since we code a dummy variable recession, now we can run the regression analysis using the 3 variables here: radio advertising, newspaper advertising, recession. So go to data analysis. Okay, so now regression one more time, click on OK. So input Y range is going to be, yes, we have it already. So this one, we're going to do this, right? 3 variables. So it's a B1 all the way to D23. Now label, yes, we included title, confidence level, that's good. Now change the cell we're going to use, we're just going to put it underneath it. Right, so we can compare them one by one. Maybe put it on the side. No, I think it's a good idea to put it underneath that. So I'm going to put it right here. So F37. That's what I put. So that's good. So let's see the Excel outputs. Okay. So now, one more time, this is a model 2. So let me just make it clear. This is model number 2. See if the model number 2 is better compared to model number 1. So we're gonna let the Excel outputs tell us how it goes. Okay. So first of all, we're gonna take a look at R square, right? So if you look at R square here, 88.87%. 0.24% of the variation in sales is explained by the variation in three variables. First one is radio advertising. Second one is newspaper advertising. Yes, and also and the third one is a recession, whether or not that's recession. And, recession. Okay, so that's basically how we interpret the R square. And also we're going to interpret, adjust the R square. See if this, okay, so by adjusting the amount of independent variable used, so end up with 86.29%, 86.29% operation. Again, adjust R square slightly smaller than R square. Sales is explained or interpreted by variation. Three variables right now, three independent by radio advertising, newspaper advertising, and then recession. Third, recession, whether or not that's recession. Right. So that's how we interpret this. And if you just look at adjust the R square, this is bigger. So meaning the model 2 is slightly better. Right? It's better compared to model number 1. But we're going to conclude that in a second, once we finish all the interpretation here. And the sample size the same. Okay, so both of them same sample size 22. Now let's look at the overall model here. Okay. Yeah, so the ANOVA outputs here give us an overall model whether it's more effective. Okay. So F value, if you compare F value, I think it's slightly bigger than the previous model, right? So I'm going to label in the different colors. And also this is P value. Okay. So P value, if you turn this into a decimal numbers, it's going to be slightly smaller compared to the first models. Meaning the second model is slightly more significant. So there's a stronger linear relationship in the model number 2. So let me highlight this. I'm putting different colors so you can compare them. Yes. So here, since the p-value is smaller than alpha, much smaller than alpha, meaning we are rejecting HO. Reject HO. HO is, and there's no linear relation. So beta 1 equal to beta 2 equal beta 3, right? Meaning all slope here is equal to 0. Okay, so since we reject that, that means that's linear relationship. So with 95% confidence, 95% confidence, we can say that there's a linear relationship. And compared to model 1, it's stronger linear relationship, meaning the second model is better. Between sales and three independent variables. Radio advertising, newspaper advertising, and also recession. whether or not there's recession. So recession. Okay, so that's how we interpret overall model, which is ANOVA output gives us the effectiveness of the overall model. Now, once again, we're going to look at so no resection we indicates it's at 0, right? So there's no resection, then no resection is 1, right? So that's a recession is 0. So we need okay. So I'll do this. So this is regression model here. Regression model. First one, let me just. So the predicted sales equal to so intercept, which is so 385. Then let me just run it to 3 decimal place so we can write down the regression model quicker. So it's 385. That's y-intercept, and y-intercept here has no real meanings, so we're going to skip that. Okay, it's going to 9.036 times radio advertising plus and 9.082, no, 9.842 multiplied by newspaper advertising. And adding 282.228 as recession. So no recession multiplied by 1. Yes, there's a recession multiplied by 0. Okay. Meaning, without a recession, the sales will go up by 282.228 units. Right? So that's how you interpret each one of these. Each one of these slope. So maybe let me first of all let's interpret slope number 1. So interpret B1. B1 here is a 9 point, so let's look at each one of these. So B1 here tells us if the radio advertising spending goes up by 1 unit, and sales will go up on average. Sales will go up by 9.036 units, 9.036 units. Okay, so that's an interpretation of B1. And for B2, which is interpretation B2, if the newspaper advertising spending goes up by 1 unit on average, the sales will go up by 9.842 units. Holding the other two variable constant, holding, yes, I forgot to put this language here, holding the radio advertising and reception constant. Same thing for the first one. I should put in the language here. Yeah, so B3, which is the resection. Okay, so B3 interpretation B3. If there is no resection, then the sales will go up by 282.228 units, holding the other two variables constant. The other two independent variable constant. Okay. So basically, that's how you interpret B1, B2, B3. So now let's take a look at how let's perform all the. If you look at all these p-values, they are also very, very small. So all the p-values are smaller than alpha. So they basically so let's test for beta 1, right? For beta 1, beta 1 here is for radio advertising. The p-value is smaller than alpha, so we reject HO. HO is B1 equal to 0, beta 1 equal to 0. And that means there's a linear relationship between radio advertising and also the sales. Okay. Yes. So we take care of beta 1 and for beta 2. Beta 2 is slow for radio, no, for newspaper advertising. So p-value also it's quite small, it's very, very small. So meaning that indicator, the independent variable is significant, it's very significant. So again, reject HO. HO is beta 2 equal to 0. So that's So I'm going to put in another way. Newspaper is a newspaper advertisement. A significant indicator of our sales. Just another way of saying this. So for beta 3, for recession, which is dummy variable recession. So p-value also is very small. It's smaller than alpha. Again, reject HO. HO is beta 3 equal to 0. So the recession, whether or not there's a recession, is a significant indicator. Or significant predictor of sales. Okay, so basically we test all 3 individual variables, and then so they are significant. So that basically that's what we get out of this Excel. Okay, so now if you compare Model 1 from Model 2, Model 2 is better. It's better because just R squared is better, it's bigger. Adjusted R squared. When you're comparing different models, you're using adjusted R squared. Is bigger in the model number 2, right? So that's what we see from the model number 2. Now you can easily compare them. You see this model number 2, okay, and model number 1, model number 2. Model number 2 is slightly better. Okay. So that's pretty much everything that we needed to do for this particular problem here. And also I'm going to go over house examples, right? So this here predicted assessed house value using the size and the fireplace. So here the size is the numerical data, that's okay, quantitative data, which is good. But a fireplace is a categorical data. So this is under dummy variable. So that means we get a coding. So again, once highlight the column C and then right click on it, you're going to see insert. And right here, we're going to code a fireplace as a dummy variable. Meaning if there's a fireplace, usually the assessed value is bigger, right? So meaning we are coding fireplace. If there's a fireplace, you code it as 1. So the E2 equal to yes. Now put in 1. Otherwise, put 0. All right, so now if you enter, just gonna scroll down a little bit, so you're gonna get all of these numbers, and this number should be the exact. So reduce to 0 decimal place. Now let's run analysis using the data analysis, right? So go to the first one, data analysis. Okay, so regressions, okay. So info range right here, we're gonna select this all the way to A1 all the way to A16. Upper range is gonna be B1 all the way to C16. Okay, so we call it dummy variable already. Labels, check the titles, it's check the confidence level 95%. Upper range, we're just gonna put it right here. Okay. And click on OK. Now I'm gonna run through all of this analysis in a second. What's this? So first of all, let's look at the Excel output from the first portion here. One more time, we're going to go through this analysis step by step. So if you look at R squared, so that tells us 81.11% of the variations in assessed value, home value, house value, X explained by the variation in size of the house and also the fireplace. Size of the house, size and fireplace. Okay, so that's going to be the, let me just highlight this to the color. Okay, and let's interpret adjust the R square here. So by adjusting the number of the independent variables here and the sample size, so 77.96% of variations in assessed house value is explained by size of the house and fireplace, taking into consideration of the sample size and the number of independent variables used. Taking into consideration of sample size and number of independent variables. Okay. And then again, we know the sample size is going to be 15. Now let's interpret the ANOVA output overall model. Let's see if the overall model is a good model. Okay, so this is p-value. So the p-value is also, the f-value is very large, right? F-value comes from mean of square regression over mean of square residual or mean of square error. So that's a relationship within the ANOVA table. And let me just turn into decimal numbers and then we get the conclusion out. All right, so again, this is much smaller compared to alpha. And that means we're going to reject HO. HO has no relationship, right? Meaning beta 1 equal beta 2 equals 0. Meaning there's no linear relationship between the assessed house value and also those two independent variables. So since we reject this, that means there's a linear relationship So with 95% confidence, I say that that is a linear relationship between the set house value the size of the house as well as reception. Fireplace. Okay. That's how we state a conclusion here. So overall speaking, this model is effective. Okay. So now one more time, we're going to go to detailed analysis with respect to each one of these individual independent variables. So now let's state a multiple linear regression model. So predicted house value or assessed value it's equal to, okay, let me turn into 3 decimal place. Okay, so it's 50.090, adding 16.186 multiplied by size of house in thousands, units thousands, size, adding fireplace, so 3.853. If that's a fireplace, so the assessed value will go up by 3.853 units. Okay. So that's our regression model. Now so let's interpret B1 here. So for B1, and so B1 is this. That. B1 is 16.186. So when the size, if the size of the house go up by 1,000 square feet, okay. By one unit is 1,000 square feet. And the assessed see the unit for 2,000 as well. Okay. So assessed assess the house value. Will go up by 16.186 units, meaning 16,000 times 1,000 becomes $16,186 on average. Holding the fireplace constant. Yeah, the variable fireplace constant. And B2. Let's look at how do you interpret B2. B2. So if that is a fireplace on average, the assessed house value will go up by 3.853 units, which is $3,853, holding the size of the house constant. Okay, so that's this B2. And then also let's test the hypothesis for the, if you look at the p-value here, they both very small. Okay, so let me just highlight those two values. So we turn into a decimal numbers. Right click on it, format cells, So this is 4.02 times 10 to the negative fifth power, which is very, very small. For some reason, the Excel it's acting very weird right now. So, but it's okay. So let me just quickly redo that. Okay. So as you can see, this p-value is very, very small. Right? Both of them are very, very small. That means for beta 1, we tested each individual independent variable here. So since that the p-value is smaller than alpha is 0.05, then we reject HO. HO is beta 1 equals 0. So meaning that is a linear relationship between size of the house and the assessed value. And also for beta 2, we do the same thing. So the p-value here is 0.009. P-value is smaller than alpha. Reject HO. It's beta 2 equals 0. So fireplace is a significant indicator of the assessed value. Okay. So basically run through the entire analysis and interpret all those important elements in the summary outputs. Okay, so that's so your Excel project number 4, right, will be similar to this. So you can use this as a guideline for the Excel project number 4. Okay.